our efforts into bringing interoperability. We believe that the industry requires much more data, and data that it adds actually value with high precision and accuracy data that allows you for taking faster decisions. So I see that we have a lot of people, and we are the trailblazers on the industry. So I appreciate that. So today we're going to be talking about how we are powering the interoperable mining data through our Smart Cloud API. And basically, myself first and foremost, so we can understand who is the person that is speaking at the moment, and also so we can let you guys know about who we are at SPT. I also want to say thank you to all of the people that is watching us on the streamline online. Basically, we got a lot of people. We'll have a Q&A section as well, and that is the moment also. So I'm Eric Estrada. I'm the Global Marketing Director for the company. I've been with SPT for 5 years. We've been growing quite a lot. We've developed a lot of technologies. At the moment I joined the company, we launched the Smart Cloud. Basically, it was the platform that unifies all that we do into one single platform. So SPT at Stockholm Precision Tools, we are a Swedish-born company. It was founded in Sweden in 1996. Currently, our headquarters are located in Spain, but we keep a very respectful relationship with our roots in Sweden. Now, this year, we are celebrating 30 years of history since our founder, Orlando Ramirez, founded the company, and we've been going strong. We started with gas, and that's the reason why we're bringing all of those basically standards into what we built into the mining industry. We develop everything in-house. We are a company that manufactures directional survey tools and different other tools that I'll show you briefly, but I want you guys to let you know that we design the hardware, the firmware, the software, and we also provide the service. And one of the most important services that we provide is the local support that we can actually be able to give, because we have a global presence. So we have our own offices in 12 countries, and we have the network of distributors in other 19. So we are covering the globe, so we are always in a time zone where we can provide 24/7 support. So just to briefly give you an idea of understanding why is SPT, what is SPT, or why does SPT exist, is the precision that defines our brand. So we are very happy with having that milestone, being one of the companies that basically guided the operations on the rescue operations for the 33 miners trapped in Copiapó in 2010. So that's for you to give you an idea that when precision is a must, our brand comes to float. Now, our catalog of instruments, and well, you'll see that we got a network in there, and that's basically the ecosystem that we will talk in this presentation as well, and let you know how that network and why is it important to have it integrated. So what we built is from the top, it's the rig alignment.
That's me. And in order to understand what I mean by the data scene, I think it's a good idea to take a little bit of a step back in time to the previous epoch, which is called the Qualitaceous period. The Qualitaceous period has been a pretty long one in geological history, and we can step back all the way back to the good old days of 2014, where the Australian Institute of Mining and Metallurgy put out this really good resource. It's called the AusIMM Guide to Good Practice of Mineral Resource and Ore Reserve Estimation. And the very first chapter in it has an interesting set of case studies that goes over the causes of problems that mining companies have. And if you take a look at a lot of these, the biggest group of them, the geology and resource reserve estimation, geotechnical analysis, are directly failures to understand the geology that's in the ground. And then you also have to wonder how many of these other things, like mine design and scheduling, that are supposed to be informed by the geology, where did it go wrong along the process? And so a significant number of problems are directly attributable to failures in geological understanding. Now, the rocks haven't changed. They've been sitting there since even before the Qualitaceous period, maybe go all the way back to the Precambrian. But our understanding of them has to grow and evolve in every single project that we do. And so, because we don't know what the rocks are, we have to build our understanding of the rocks as we go along. And so the reason why I'm standing up here working with SPT is that in order to do that, things the same way every time and expect different results. A lot of technology companies out there come out with products that are in search of solutions. One of the great things that we do with these guys is we've identified the problems and they come up with the solutions to it. And so how are we going to reduce that error stat? You know, the greater than a third of the problems that we see directly related to stuff that we can control as geologists. And, well, a lot of it is we're never going to be out of the geological sciences. But we can understand and recognize what the potential problems are in using qualitative data and reduce them. In the same vein, we can take a look at how we can increase actual quantitative data, things that we have that have hard numerical constraints that we can use in repeatable and predictable ways to increase the confidence in the interpretations that we're making. And all of this, hopefully, will lead to de-risking. I mean, that's the goal that we all want to have. We live in a very uncertain world and in a very uncertain industry. And I know I sleep better at night if I think that I've crossed all my T's and dotted all my I's and done everything that I can to make sure that the data that I collected that day is good and not just some illusion that's going to encourage the strength of what we are as geologists. We're not machines. Despite the best efforts of all the companies that are trying to replace us with machines, we're not machines yet. But what machines are good at is doing things the same way every time. What geologists are good at is taking that information, seeing the patterns, and testing and generating hypotheses based off of the data. And so, one of my favorite things in the mines that I get to go at is I get to see a lot of different things. There's that quote that the person who sees the most rocks wins. I like to think that the person who sees the most mines loses the least. And, you know, every mine that I go to, we have the morning safety meeting and we look at close calls and incidents. And this next section is an examination of close calls and incidents from a data interpretation perspective. And so I generally see a lot of common themes in how things go right and how things go wrong in a lot of different. Some of these are pretty straightforward. And as we go through these, I invite you all to think about how different solutions might be used in an effective way to reduce or mitigate these kind of problems. One of the biggest ones that I see a lot is geology by cross-section. Back in the day, trying to figure out what was going on in 3D space underground, we had to deal with the limitations of our own reality. We didn't have things like 3D computer modeling to be able to visualize things. We had to do some dimensionality reduction and bring things into a way that we could understand them. And that meant cross-sections. And to make good control over it, just drill in a way that makes easy cross-sections. And so drilling is often designed in this rectilinear pattern. Now, that we can control. The things we can't control sometimes are things that we have to drill around. Canada is great for this. There's tons of lakes out there. They're easy to drill on in the winter, a lot harder to drill on in the winter, a lot harder to drill on in the summer. And so and these choices that we make in order to make our own reality a little bit easier ends up in doing things like this, where you get these nice rectilinear drill grids, but unfortunately, geology isn't always like that. And one of the things that happens in these sorts of scenarios is that, well, geologists aren't machines. And so what they'll do is they'll measure things and they'll choose things to measure based off of how easy they are to measure, how confident they are in the measurement. And one of the things that ends up happening with some of the older technologies out there for measuring things in oriented core to things that are easy to measure. And a big bin of that is things with an alpha angle. If you guys are familiar with oriented core, I'm probably going to say some terms there. If you're not, feel free to ask me questions about it. Just raise your hand. Biasing by alpha angle is a pretty serious thing that'll happen, where geologists won't measure things with a relatively low alpha angle because they don't like them. They wobble all over the core, they're difficult to measure, and oftentimes low alpha angle features actually destroy the orientation line. And so you don't get these measurements using the traditional wraparound protractor style. And also, if you're drilling geology and there happens to be something there in the rocks that would generate a low alpha angle, well, it just doesn't get captured until something else happens. You either work with your workflow in order to generate a capture system that is better at capturing more difficult things, a more efficient workflow that allows geologists to capture more things that are important, but then also do things like, well, eventually get underground and start drilling. This is a project that was partially constrained by a lake that was sitting over here, and partially constrained by the fact it's a lot easier to make a drill road in a nice straight line through the tundra. But they had a nice understanding of what was going on in the geology, except for these occasional mineralized boudins that just didn't seem to hold together. Well, as it turns out, when they started drilling oriented core from an underground perspective, another population of features started to show up that was dipping pretty close to parallel to the drilling, and they weren't being sampled properly, just geometrically. And it ends up, this is kind of like a good problem to have, where you end up having a lot more contiguous ore body than you expect. But I'm sure everyone here has recent histories in mind of different failures of resource development and modeling. Well, that doesn't always happen. And so these guys, both through a good process design and a little bit of luck, got an increase to their ore body, but it doesn't always work that way. Another thing that happens is, well, geologists are imperfect. Well, other geologists, I'm perfect. We're great consultants, I swear. But for those geologists out there that are happening to be imperfect, well, it's because that rocks are hard. One of the things, I'm from Nevada. We have this beautiful carbonate section with shales in it, and it's all faulted up. Unit of limestone you're in, when there are all these gray rocks that have been variably altered. And well, if the assumption is that your process is perfect and everything that you get is good data, then you start to try to find other reasons for the patterns that you're seeing. And in this case, there's this nice little offset here in this blue unit that is pretty far up, stratigraphically speaking, from the other parts of this blue unit. And these guys were drilling what was basically a scarn system. And if you see a big offset like this, you start to think, oh man, maybe there's a fault. Maybe that's a conduit. Maybe we should target that potential conduit for high-grade mineralization by beat a hole down into it. That's a pretty expensive bet to make based off of something like a single offset seen in a drill hole in rocks that are very difficult to understand. And so before you do that, and before you go off making an assumption like that, it's better to test your assumptions based on something a little bit more quantitative, something like geochemistry. And what this hole turned out to be was the new guy. It was the first hole that somebody who came on site had logged. And if you look at the geochemistry of that hole down here, these dots are all color-coded by some immobile elements. Well, it's all jumbled up. But if you look at the other holes, you get a nice distinct variation in what those geochemical descriptors are saying. That's suggesting that if you rearrange this so everything is where it's supposed to be geochemically, this offset goes away. It wasn't a fault, it was just a fault with the logging. And where this went sideways is the fact that there wasn't a lot of visibility in this data. There was no way for the project geologists to easily access and get into this. Things were in different tables. There wasn't an easy way for people who were off-site experts in order to be able to access this stuff to vet and understand what was going on. And so even though everything was there to make that decision. Luckily, this was a close call, and they didn't put a 2,000-meter hole through a non-existent fault that was going on right here. So another one, and this is a pretty common one, I'm a pretty data-driven person. I'm slowly teaching myself the fundamentals of data science, and what we appreciate is how overworked and underappreciated the database admins are in most geological operations. They do a lot of stuff, and they usually don't have nearly the respect and resources that they need to do it. And so because of that, the stuff that they end up doing, data schema design, the updating of tables, it gets pushed to the wayside because they have to deal with messy imports and all of the things that should be automated but can't be because the rest of the process isn't really interoperations into an existing data structure. A data structure should be customized to make your observations in an organized and rigorous manner that allows them to be used very easily. And one of the things that we see regularly is, well, we're going to measure structural geology, but the database person doesn't have time or the mandate to make another table. So let's just shoehorn everything into a single thing. Well, point structures, things that you measure off of oriented core, and other structural data that you would measure as an interval are different data types, and they're used in different ways. And so trying to extract point structure data, things with an alpha and beta, from interval structure data, things with a from and a to that don't necessarily have a single geometry to it, it's difficult, it's time consuming, so it doesn't get done. The other thing that often happens is going back to that beginning where geologists love to measure things that are easy to measure. Well, are they measuring the things that are geologically relevant? One of my least favorite things to come across, especially in Canada where we have all these beautiful dark mafic rocks that are hosting gold deposits, is how often we get data sets that are all white calcite veins in dark mafic rocks. And that happens because they're easy to measure. They're like, look at this. This is here. It's organized. It's beautiful. I'm going to take a measurement of it, but is it important? And when you just look at a graph and a table, there's really no way to understand if what was measured was important. So having a way to validate, and that's a critical thing to be able to do. But a lot of other methodologies out there don't have that ability to do it unless you want to go through and look at core photos, which is a great thing to do on a rainy day, but it's not something that I want to have to do every day. Makes your carpal tunnel act up a little bit. So having a way that all of the various data streams from all of the different tooling comes together in a way that allows both the data collectors to validate what they did, make their own corrections, but also the data managers to be able to understand and manage the process is very important. Issues that'll crop up as you start to get more and more data that makes the data harder and harder to use. And so now we've talked about some of the failings at it, and we all have this idea in our heads, hopefully, that, well, yeah, we should be doing some QA, QC on it. And one of the worst things that can possibly happen is the illusion that you're doing good QA, QC. It's very easy to say that you have a process in place, but unless you're regularly looking at what that process is saying and how any errors are affecting the data, you're not actually doing any kind of quality control. And so in this case, these guys were doing a beautiful job of orienting core, measuring lots of structures at a regular basis. They have a quality control system in place that's giving some understanding of what's going on, what's accurate and what's not. They also have, a tool in place that they can look and see what the data is. But unfortunately, these are all lithologic contacts. You can see how often they are almost exactly perpendicular to the drill hole. No one thought to check if they were using the tool properly. No one actually went and looked back and said, hey, is this contact right here really at 90 degrees to the core axis? When you go back and look at the photos that they had available, it's not. And so there was a gap in their QA protocol that they never really assumed that was there. It's like, are they using the equipment properly? Is this being done according to the standards that we have? And so doing all this stuff right enters you into the next step, enters you into the data scene, which is where hopefully we'll all start to be living and avoiding destruction as much as possible. All of this is moving towards is an idea of truly quantitative resource and geological modeling. There's a British statistician, he's got a lot of pithy phrases, but one of my favorite is, all models are wrong, but some are useful. And we're not necessarily trying to absolutely turn the Earth into a realistic, 100% accurate model in our hands. We're trying to create a model that is useful for the purposes that we want it to be useful for, which for us is where's the resource and how do we get it out of the ground at a profit. And so when you have full control over good data at a high enough density, which you need to capture efficiently in order to get that density, and you have good quantification of error, and you have vetting and validation throughout the entire process, well, this is in Leapfrog, and one of the common complaints that everyone has in Leapfrog is they say, well, it generates these bubbles, this unrealistic data. Well, all the knobs that you turn in Leapfrog or any implicit modeling software in order to turn those blobs into realistic data are structural ones. And so if you have good high quality data that you can say, okay, this point here is accurate to within X degrees. This point here is accurate to within Y degrees. You can guide a model almost automatically to create a very realistic and testable hypothesis, which then you can weight. The color scoring on this, it kind of got cut off here, but it's a confidence weighting of how accurate that model is expected to be at any particular point. It's based off of drilling density, it's based off of the accuracy of the control structural points, and this model continues to be tested relatively accurately in places where it has good input. You don't know, and it's a little bit more exploration focused. But what that does is it allows people to quantify how much risk they're doing. Are we drilling into an area where we have good control? What can we expect? Or are we not? How accurate do we expect our resource model to be in a particular area? How well do we understand the controls on the geometry of the ore? All that can be done when you have data plus a quantification of error, which is controlled through a good process of quality control, as well as a good process of managing ability. So I think everyone here, I don't think you're all at one particular mining company or doing one particular project. And there's a spectrum of things that need to be done. And I like to break it out a little bit bimodally into smaller projects and larger projects. But as I go over some of these goals and potential problems, I invite everyone to think about where your project sits in this spectrum and what kind of ideas that you can pool and what to talk about. And so for small projects, one of the biggest things that I see across everywhere that I go is managing both consistency and accuracy. I put consistency first because when we're logging, that's honestly the more important thing. It's more important for everyone to be calling something that they see the same thing, the same all the time, than it is to actually really know what it is. That interpretive step can come later. What I teach geologists is like, I don't know what you call it, but if everyone's calling it Steve and everyone knows who Steve is, that's important. And we can figure out what Steve means geologically. The next part is flexibility. And this is especially important for a small project because you never know what you're going to encounter. You have to have the ability to be flexible with what you record. If you're all of a sudden drilling and you encounter fluorite and you think it's going to be important, you have to have a way to log and accurately capture fluorite. But if your data structure is inflexible, well, that ends up in comments, it never gets used, and it gets lost. But that flexibility has to come along with consistency as well. It can't just be left off to the geologist to decide where they want to put certain things. And that goes along with the annotation and metadata. You have to have the ability to capture information about the stuff that you're logging. You can't just say limestone. You have to have more than that. You can't just say, here's a vein with an alpha and beta. You have to have more than that. Because the more information that you extract out of the core, well, you paid for it, you might as well get it, and you have to extract it out in a way that's usable, that you can answer questions with later. Is the key. Maximizing the value. I mean, how many times is like maximize the value of your data set? And the thing that is implicit in that statement is that your data set has value. And I'll go to the very end of the extreme and say that every project's value is entirely in its data set until that metal comes out of the ground and gets handed off to some guy and you get a check from it. Every resource model, every mine development model is all numbers in a computer until that rock is in the process mill and comes out as a doré bar on the other side. And the value of what they have is in the ground. kind of true, but you don't know what's in the ground until you translate it into a model. And so I like to think that if you think about what your company's value really is the data set that it generates, you start to understand why this process becomes a little bit more important. And so all of these potential goals have failure modes. We've talked a lot about them. One of the big ones that I like to stress to everybody is to remember that Excel is not a database. Excel is not a database. Having a good, high quality allows you to use the data. It allows you to have the data set up as value. And so for small projects, hopefully all of them evolve, you hit targets, you find more resource, and you end up as a big project. Well, some of those problems are a little bit different. You still will struggle with consistency and accuracy. That is even more problematic on a large project. When you have 3 or 4 guys on a hillside logging core, it's pretty easy to get everybody together and fix how they're logging. But if you have 20 or 30 logging geologists and they're scattered across different shifts, it becomes exponentially harder to make sure everybody's on the same page. So having processes in place to do regular data review and regular data quality control becomes even more important because the consequences of mistakes become much larger. And that's because of the additional volume that large-scale projects have. And managing that volume is where a lot of the more new exciting technologies are coming into play, things like core scanning, things like other machine learning methods for managing large data sets. And some of the tricks for smaller companies is how to grow into something in a scalable way that allows them to start to use high volume data processing things. How can you generate a data set that might be good for training a machine learning model? Like what can you use to generate a high quality structural data set with annotated images? This is a strong segue into the Struckmaster. I love that thing. The other thing is process management and visibility. Every large operation that I go to has the geologist in the office and the geologist in the core shack. And the and have visibility into that is even more important at a large project. And the last bit is the accessibility and interoperability part. As you grow and get bigger and bigger, more people are going to want to have their fingers in your data. More third-party consultants, people like me who just love dipping into people's data and see what's going on. Different tools, engineering firms, all with different goals and different needs. And the ability to extract the data that they need to do what they need to do in an efficient and easy way, well, it saves you money because consultants bill by the day. Ask me how I know. But it also allows that data set to be used in a much more efficient way. It allows the data to be shared and to be seen by more eyes. And we have, if everybody in this room has 10 years of experience in mining, we have centuries of mining experience here. And so the more eyes that you can put on a data set in a meaningful way, the more likely you are for someone to see something and extract something of use and of value to the project. So I hope that gives everyone, and of course we can talk about the failure modes too, but I think I'm going a little bit over time. But I hope that gives everybody an idea of what the data should look like. Now, implementing this stuff requires processes and tools, and I mean, just coincidentally, I happen to be standing here in front of people who make tools. So I believe, Justin, you're up next. Justin's going to talk about some of the new stuff that SPT has coming out, the API integration, right? Yeah, that is going to allow all these tools to talk and to be doing exactly what I'm doing. So thank you, everybody. Be here for questions towards the end.
Thank you, Jeff. Jeff started off with, well, good morning, bonjour. Joe, guess it's a little late now. It's 15 minutes after, so can't say that anymore. Let me see. Oops. Hi, so first of all, who is this guy talking to you? I'm Justin Ho. I am the sales manager of SPT Canada. Just a little bit about my background. I am not a geologist. I am actually a computer scientist. My background comes from computer science. I spent about 20 years in the oil and gas industry, building up network systems with drilling data. We built one of the biggest networks out there for oil and gas to connect all their vendors with their E&P producers. So what I'm trying to do is bring that into the mining industry. Here we go. Before I get started, or one other thing, Eric kind of put me and Jeff in the room together, and it's just like, well, let's get the geologist to start talking to the computer scientist. And I'm like, how do I get this guy to actually relate with me? Jeff gave me a good definition. Geologists and computer scientists, we have the same thing in common. One's just an introvert that spends too much time inside, and the other's an introvert that spends too much time outside. So I love that definition. That's how we relate with each other, and this is how we actually connect all the information that we have together into one system that we're going to talk about. So as you know, SPT, we are a tool manufacturer. We are the one that probe down into the ground to actually collect where your azimuth is, what your dip is, and everything. So in the old days, in the, what'd you call it, the data scene? Or the
Qualitative.
The qualitative scene. Back then, you would read from a digital screen on the tool and actually write it into your notebook and put it into Excel, and that was how you collected your data. Let's move away from that. What SPT has invented is what has designed is our SPT Cloud. So this is a SaaS satellite phones, so we're always connected now. We are coming into a world where everything's always connected, so there's no reason why that data has to sit on those rig sites anymore. Why can't we get that data into environments like this and then get it into your hands a lot faster so you guys can be in multiple places at once? Oh, two, this works both ways. You guys can actually set up everything that you need for the field. You go in here, create your projects, create all the holes that you need, so that way your guys out in the field aren't trying to guess what your hole ID is. You guys have weird naming conventions for hole IDs. Well, let's do that all for the people who actually know it, and then send it out there, and then they just pick from a drop list of what project this is for, what hole this is for. It makes things a lot more organized for them, and that's one of the things that this system does. Again, we have multiple tools, so the tools actually information together too. So now you're not dealing with separate Excel sheets where you're trying to tie all the information by doing a pivot column on the whole ID and the project name. The system will do that all for you, and this is where all our data actually sits. Okay, so like I said, it's a centralization of all the data where it all sits. Where it all sits. SPT did a great job of actually creating filters, creating sorting sections, creating stereo nets. So this is not just a system where you can actually see the raw data. This is a system that you can actually use and actually make decisions out of. We also have an approval system in this as well too, because we know that the data just sitting there isn't practical. Someone actually needs to look at it, validate it, and make sure it's actually correct, so that way the drillers can actually guys want. So that is our check for all QA QCs with the approval sign-off. And then with any of these sign-offs, we have a date timestamp, so that way you know who actually approved it. With dual authentication, you may have heard that term. This allows us to be SOC 2 compliant, iOS 27001 compliant as well too. So that way you know that the person who's signing off on these data, on your data, is actually the person who is responsible for that. And again, in this system, you can dictate who is the people who are actually responsible for which ones, who can actually see this data, and who you actually want to share this data with as well too. So if you're a driller using these tools, you just assign your client access to this, they log in, and they can see all your information right away. Give me 2 seconds here. Something's not. Send it on its way. Okay. And then, of course, once from there, this is where the problem we see today. So the survey data itself is not enough. That's what we're kind of seeing. People are greedy these days. They want to layer this data on with other data, and this is what we actually need to actually get to the scene that Jeff was talking about. How do we paint the full picture? You need to combine your GIS data with the survey data, with ASCII data, and even layer on cost and pricing as well too. So that way you can see the full picture of your entire project, where this is all costing and everything. But how do we do that? SPT, our smart cloud, we can't import all that information. We don't want to import all that information. You go walk on the trade floor, you'll see tons of software companies out there. Everyone out there is solving a different problem there. The problem we're seeing now is how do we tie this all together? Called APIs, application programming interfaces. So APIs are your roadmap of how you actually talk to systems. Software to software, the roadmap allows you to either do a pull or a push method using APIs. APIs, once you do a pull or a push, it's usually an XML or a JSON format that contains the data, and it's usually encrypted. So that way, when you're passing data back and forth, you know that it's a direct method as well too. So again, with APIs, you also have to make sure that the correct people are pulling in the information. The nice thing about having the system-to-system information is the other software that we're trying to get the information from, they have their own security protocols, they have their own user levels, and they have their own logins and everything. We can use that information to connect with what we have in Smart Cloud as well too. So that way you know that the right person is pulling the right information from the Smart Cloud system. We do, if you have the right key, then you can access the right projects and the right hosts in the Smart Cloud environment, and then pull that information directly. So again, this makes sure that we're SOC 2 compliant, we're iOS 27001 compliant as well, to make sure that the right people contain the right data, and that the fact that it's all encrypted and there's no tampering along the way. Oops. I'm sorry guys, I realized I was on the wrong slide. So where are we going with this? Well, one of the first people to read our roadmap is a company out there called Core Plan. Up next is actually Christian, who's going to be telling you a little bit about Core Plan here. But why Core Plan? Why are they the first ones to actually jump at us as well too? I won't steal too much of Christian's thunder, but Core Plan is a system where drillers can actually go in shift reports, their plots, information. There's costing in that as well too. So it is a very powerful tool where when you're in the system, you log into what's going on your project. So what better system than the Core Plan system to load our data as well too? If you're going in there trying to see what's going on with your hole already, why not see the survey data in that system as well too? One of the things we're trying to remove is having multiple systems where you have to log into one system to see your survey data, log into another system to see your costing, and log into another system to see your ads. Okay, and like I said, these are kind of backward. The problem today is it's a very manual import. That's why we're moving away from this. A lot of systems say, hey, we can integrate with your system. And what they do is they just generate an Excel file or a CSV file, comma separated value file. And then they import that file and they say, oh, we have an proper integration. People can tamper that file can get lost. There's no traceability. There's no access control with that as well too. So that's where those APIs come into place. And this is why we're actually developing it. So we're breaking this down into a few phases. The first phase is let's just get our data out there to actually pull our information. Right now it's just survey information that you get from our thing. But moving into the future, we're going to be looking at two-way communications with this as well too. So how again it works, it's just using our APIs that allow you to connect directly into our Smart Cloud. You pass us that API key that lets us know you're an authorized person to actually come in there and get it. This is for what whole ID this is for, and then grab that information. Beauty about this, it's a live system. So if we had to redo the survey for whatever reason, the second you're doing that call for that API call, you're pulling the most recent data. Okay? And then again, immediate benefits, we're eliminating human error. There's no more trying to select which column fits into what area, what data format this needs to be in. All that information is handled directly. So the last part is, that was phase one. Eventually what we want to do is have Core Plan actually be able to handle approvals or something in their system as well too, and send us back a message. So that way the systems look like they're talking to each other. We don't have to log into multiple systems. You can log into one system, be able to handle everything you need to do in that system, and then it sends everything back to our system, and then we can talk to the drillers. So that's how it's going to work in a nutshell, and explain a little bit about Core Plan and how that's going to work here.
Good. Yeah, this is good. Hi, thanks Justin. Thanks SPT for inviting us over and be here. This is quite exciting for us, be part of this launch, and yeah, this is exactly where we want to move to help you guys, right? To make your life easier and your day-to-day. So my name is Christian More. I'm regional manager for the Americas. A little about myself. I've been in the industry for almost 20 years, about 12 years in the drilling industry, and the last 6 years more in the mining tech space, which I find quite fascinating because help me to make drilling companies and mining companies more efficient. But I would like to have a sense on the audience, so maybe by show of hands, who is working for a drilling company here? Okay, good. Mining company, geos? Okay. Lawyers? Okay, good. Then we are in the right room. Great. Now this is a joke aside. Actually, this is good because Core Plan allows exactly that, a collaborate drilling and mining company. So you are definitely in the right room, and that's exactly what we do. We provide tools for you guys to collaborate each other and make your life easier on the day to day. Okay, so I have okay. Today I'm going to talk about drill program operations and what tools do they use in terms of softwares and the complex friction that they have on the day-to-day. And we'll discuss about the fragmented workflow, and that brings us to the feedback loop, which is also broken, and how Core Plan comes in play to close that gap. And finally, I'm going to talk a little bit about the Core Plan and SPT Smart Cloud. I'm just going to show you, dive deep on that. Good. So, how companies run drill programs today? We tend to see these three different scenarios. Very common. Companies, mostly junior companies and a lot of major companies, are still on spreadsheet and paper. They use that to run their drill programs, budgets, and track drill performance. Yeah, they're still on that, unfortunately. But good thing that many companies are seeing the benefit of moving away from the spreadsheet. So we see companies with adopting custom solutions. They go reach out a consultant, help them develop something for them, which is pretty good. It's definitely a step forward in the right direction. But it's quite rigid. It doesn't allow any flexibility, and they have to go back to the consultant to keep developing, and they rely a lot on third parties. And finally, we see traditional softwares, which are softwares that have not been designed for this type of workflows, which are not ideal. Interesting enough, something that all these three solutions have in common: they are far from being providing information on real time. And good. So, wow, that's fancy. I like that. This is quite interesting slide. Quite chaotic, right? And I have a couple of colleagues, when they saw this, they said, that's awesome. But that's exactly how most of the companies right now run their drill programs. Users start with mine planning or drill hole design tool. Could be Leapfrog, could be Origin, could be data mine. And basically they design the drill program, depth, coordinate, and all that. They downloaded it, put it on Acquire, and then they also put it on Excel, send it to their contractors, drill contractors by email, and that's where drilling programs start. Drill contractors record their daily shift on a paper, then they put it on Excel, they share it to their clients via emails, and that's when they start the back and forth, and a little bit of friction happens there. Of course, we all know that. But once the drilling is done, or as it's going, as drill holes are finished, then that information is put on a spreadsheet, which then goes into Acquire as well, or update other silos. A lot of frictions, basically a fragmented workflow. And what basically we have critical operation business decisions are based on delayed or incompleted data, what brings us to exploration managers not having real-time information, no visibility. They don't know what's happening on the project, right? They learn days or weeks later. Geologists and exploration basically. So by doing that, then you don't trust in your data, you don't know what is good, what is bad, which also get us to budget leakage. Basically, the feedback loop is broken here between contractors and exploration teams. Information flows one way, leaving plant statics are disconnected from what's happening on site. Promise next time go paperless. So that leads us to Core Plan, and why Core Plan exists to close the gap between planning and execution. We have one simple goal: plan, track, and deliver better drilling program without spreadsheet chaos. How do we do that? Basically, Core Plan is a SaaS platform with an app device that you can download on your phone or your tablet and capture the information there, either online, even you have offline field ops. They are on the field, they can record all their tasks, and as soon as that device goes into the cloud, has any connectivity, information goes to the cloud, and then you start understanding what's going on with all your contractors and field geos. But to do that, what we need to do is connect the full ecosystem. So Core Plan is your drill contractors, earthwork contractors, geophysics contractors, survey tool providers, basically external stakeholders to collaborate with your internal stakeholders, planning team, geoscience, drilling, data, field ops, right? But not only, also within them, right? You are providing a platform for collaboration and to share information in real time. Banking on geological database, MWD, modeling tools, resource development. It's basically one source of truth. That's what we are bringing to the table. So this is how we see the full workflow and how we support it. So with Core Plan, we do planning, pre-drilling, drilling, post-drilling, and reporting. And inside that, we have drill hole approvals, budgeting, contract drills, rig schedule in a minute, just to show how we help with the process of one of these items that we see here. But we also support sample dispatch, tracking survey, and visualization, service visualization, as well as on the post-drilling, cost summary per rig, tenements, and of course all the reporting. So this is just one example of how we improve process within your drilling programs, and this is the flow of a drilling report, plot, or timesheet. We call it so many different ways, but the driller start by entering on their device the daily activities, the drilling report. which then the geo on site can go and review it and approve it and sign off there. First approval, then goes into the supervisor, drill supervisor for review it and a final approval, and then later on goes to the senior geo. All this is quite flexible. It's not rigid. You could skip some of these steps, but what is key here is now you have visibility. You know the what, when, and who, and that's what really matters. Having more traceability and understanding the entire process, which that brings us to the three hallmark of efficient drilling programs: time, budget, trust. So basically, less manual entry, much less work, and faster reporting. Budget, better control and no surprises, and trust, more confident in the data. But in order to do that, you need to do something. You need to get all the systems talk to each other, especially if you want real data on real time. And in order to connect the systems, there are two ways on doing it: open and agnostic, or closed product suites. So open and agnostic allows you to integrate best class tools, get to choose which tools you want. Systems are connected via open APIs, and incremental adoption and lower transformation risk, which is something that we know it's tricky when it comes to adopting new process, new technologies, right? So this definitely allows a much more flexible approach. And when we talk about closed product suites, well, single vendor, all-in-one offering must adopt the full ecosystem to maximize the value. Integration primarily within the vendor side. But at Core Plan, our approach is open. We talk, we integrate with all the solutions and some more. We have an open approach. Basically, we work with your tools, the ones that you chose, and we connect them. And that's why today is very important being here and talking with the SPT guys. We are super pleased on seeing this happening because, SPT definitely provides data that we want to integrate on our platform and make it available to our clients. So this is just an image being shared by the SPT guys in terms of how you can visualize drill hole and deviation on demand. So by doing that, you secure data, transfers data is audible, traceable, no more manual CSV files as Justin was saying, right? And so the data is more reliable. You see course corrects shift by shift and make critical decisions faster and more accurately, right? That's what we all wanted. So I'm gonna finish this presentation my short presentation with a quote. This is a real quote from a tier 1 miner. And actually we see this and we know this is true. It happens every day, and basically says, at our operation, a drill hole can be technically acceptable today and technically invalid just a few days later once deviation data is finally reviewed. Finding that out after one shift instead of 1 week later changes everything. The value of connected survey data is simple. The sooner we can see deviation, the cheaper it is to fix, and more confidence of our geology team has in what it comes next, right? Hopefully you see this, you're familiar with this and you relate to this. So
out there. We're talking of lots of other systems. Like I mentioned, every system that you're talking out there does something different and does something better in every different way, right? So how do we connect all the systems that do something that's really good into one system so that we get the proper information from all the systems. So again, that's what the APIs are all about. We're going to create that roadmap that allows you to actually pick and choose what information you want to pull from the SPT Smart Cloud and what information you want to push into the SPT Smart Cloud as well, making it all convenient, making one system your record of truth where all the systems are synced together and all the data makes sense together. Okay, and with this, everyone's wondering, well, when's this going to happen? So a release date for all these codes, all the roadmap, it's all happening on May 2026 this year. So stay tuned for this information. As soon as it's there, we'll be releasing the technical documents that you need to understand how you can actually read these APIs from the SPT cloud system. Okay, and what does this QR code do? It just gets you.
Yeah, thank you. So we can scan that. I think we got set this up for the basically a subscription to get an early notification, so we could have some early access. So if you're interested into basically trying any of the systems and try the actual integration, there's going to be an early access. So we're looking forward to find the partners that we work together. We know that we work with several companies that are using Core Plan at the moment. So we are going to start with them. But if you are interested in integrating this platform or our tooling, the early access, then we'll be more than happy to test it out with you guys. And that will be before May 2026. So this is open right now.
So thank you again for attending this presentation. I hope you guys are enjoying PDAC 2026. We're up here. We have our live stream. There's ability to ask questions on the live stream. But anyone in the audience, if you guys have questions, anything that we can help answer, we're opening it up right now for any questions that you guys might have. Anything online?
Looks like we don't have any online questions at the moment. I'll open the invitation to ask any questions regarding both Core Plan or SPT or the integration whatsoever.
Okay, everyone's probably ready for lunch. So thank you again, everyone, for attending this session. I hope you guys got some good information from it. Again, SPT is at booth 441 over in the South Hall. So if you guys want to ask any questions to us directly, feel free to do so. And thank you again.
Thank you.
Very good. Thank you, sir. Crushed it.
No, pues llórale.